Hi, I want to show you how to start out, create a project, and do some very simple calculations inside Visual Studio 2019. So I've started Visual Studio, and I'm going to click here to create a new project. And it asks what kind of project do I want. So there's all kinds of projects here, and it remembers what I've been doing recently, which it seems to think is C++, which is not really what I want. So let's just see if we can find, it's an empty project, provides no starting files, and C++ Windows console. That's what we want. So you may have to search through this list a little to find it because it can be a long list, but there's actually a search up top. And if you search for empty project, it'll speed it up. Anyway, this is the one you want, C++ Windows console. Then we click next. And you get to specify where you want it stored. So I'm going to say, okay, when BTM 200, and this is on my online stuff, which is here, and it's associated with my videos. And this is going to be, let's see, am I in week 1 or week 2? I'm in week 1. And what I'm going to do is I'm going to create a new subdirectory or folder, and I'm going to call this SRC for source. I'm going to click that, and now it'll store whatever I create in that directory. And I'm going to call this variables, because I'm going to explain what a variable is and how to start using it. Okay, so I'll say create, and it spins for a few minutes, and then it gives us the full compiler. Under source files, I'm going to right click and say add new item, and I'm going to say I want a C++ file, but I don't. I'm going to come down here and I'm going to rename it, and it must end in .c, and that makes it a C program instead of a C++ program. So we're using a compiler which can compile both C and C++ because they're very highly related languages, and by putting .c at the end, that tells us it's a C program. So I'm going to click add, and now it gives me a blank space up here where I can type my program. I'm going to start and define a macro and that will tell it when it imports the IO library to not be concerned about this security problem, because they said, oh, scanf has got a security problem, can't use it, we have to use scanf_s. But this doesn't work well in other compilers. So to make the code we type here work with other compilers, we're going to define that. You have to define that before you include the standard IO library. And that's how you bring in the standard IO library. And that contains scanf and printf, which are the things to read values off the keyboard and to print values out to the screen. Now I'm going to declare my main function. And put in the body, which will initially be empty, but I'm going to say return 0 at the end because I'm pretty confident my program will work. Now what I'm going to do, I'm going to define a couple integer variables. And that creates two variables of type int or integer. Now those variables cannot have fractions, they're just whole numbers. I can assign to these values, and they're called variables because you can change the values whenever you want. So I'm going to assign a value to them, and I'm going to say alpha equals 6, semicolon, and I always put a semicolon at the end of the lines, and beta equals 9. Now, I think I'll go create a new variable, and I can just create as many ints as I want, listing them out like that. And now I can say that gamma equals alpha plus beta. Now what that's going to do, it's going to take the values stored in alpha and the values stored in beta, add them together, and assign the result to gamma. So I can print this out, and I can say printf, which is my main print statement, and printf has no idea what the data type is. So if I just said print gamma, it would say, well, I have no idea what gamma is. I know I just declared it and told it's an int, but printf doesn't know what it is. I have to make that printf. So I have to put in what we call a format code. %d is for integers, and \n tells it to print new line, comma, and I'm going to print gamma. Put my semicolon at the end of the line, and I'm just going to say gamma equals %d. So what it's going to do, it's going to print out gamma equals, and when it sees this %d, it's going to match it to the very first variable after the comma, fill in the value of gamma there, and then print a new line. You're going to see that I'm going to be able to use printf to specify multiple values, and I'll show you how that works in a moment. What I'm going to do right now is run this program and give you an idea of what it looks like when it runs. So I can go through the whole process of building it to make sure it builds properly. And it says here 1 succeeded and 0 failed. So you should see 1 succeeded. If it didn't say that 1 succeeded, there'll be error messages up above that tell you what went wrong. Okay, now we can go to debug, and under debug say start without debugging, and that will run our program without debugging. We'll talk about debugging later. So let's run it. And it says gamma equals 15. Down here it says process exited with code 0. Code 0 is good. That means that our program was successful. And it says that 9 plus 6 is 15. So we're lucky our computer can add. Now, in addition to ints, we can also have floats or doubles, which are floating point values. Let's say something costs $2.50, and so we can say that something is $2.50 and the tax rate in Ontario is 13%. So now I could calculate the final price, and I can write this down here. And I can say the final price equals the price times the tax rate Now, when I multiply that, that will actually give me the tax. And to figure out the final price, I have to add the price onto it, like that. Now, the way arithmetic works is multiplication is done before addition. And these are simple rules of arithmetic that you probably learned way back in grade 4 or something. But it does multiplication and division before it does addition and subtraction. In order to make sure that everything gets done in the right order, we can put these parentheses around it, and it'll do things inside parentheses first. Now, this actually would have done things in the order I wanted anyway, but I put in the parentheses just to make sure. Okay, now what I'd like to do is print that out, so I can say printf, and I can say price equals. Now, because these are floating point numbers, I don't use %d because that's for integers. I use LF, but I want to specify, because it's money, 0.2, which says 0.2 or 2 places after the decimal. So that's going to print out a long float, which is what a double is, with 2 places after the decimal, comma, and with tax equals %.2 LF. Backslash n to put a new line there. And now I'm going to have to put in the variables that match up with the format codes. Now the first format code is the %.2 LF, and that's the price. So to match the first one with the first variable, I put in price. I put a comma because there's another variable. The second format code is going to go with the second variable, which is the final price. I put my semicolon at the end, and it should tell me what the price with the tax is. Save that. Now I can just go straight to start without debugging, and it'll rebuild and run it for me automatically, or I can go through the build step, it doesn't matter. Okay, so it says my price is $2.50, but with tax it's $2.83. Once again, I check my exit code was 0, so the program worked correctly and there's nothing to worry about. So this is how we can get the computer to do all kinds of calculations. We start out by declaring variables, which are named spaces in the memory where it can store things. We can initialize them or not. We can assign values to them. We can perform calculations and store the result of a calculation in new variables, which is what we did down here. And we can use printf to print out one or more of the variables with strings mixed in. And this is the basic idea of how we write our computer programs.